Hi, I'm Peter Weiss-Penzias at University of California, Santa Cruz, and we're studying the amount of mercury that is in marine fog. Now, fog is an extension of the ocean. The atmosphere becomes saturated with small water droplets that don't necessarily settle out. Rain comes down from high in the sky, but fog is a layer of air that has 100% relative humidity, and those small droplets need surfaces to land on before they can grow into larger droplets and sustain the soil with groundwater and these beautiful redwood trees. One thing that's different in what we're doing is looking for toxic mercury compounds that are contained within the fog. And in the ocean, deep in the ocean, mercury gets transformed into a toxic form called methylmercury. And this is a natural effect. The bacteria that live deep in the ocean, where there isn't much oxygen, they convert mercury atoms into an organic form of mercury called methylmercury. And along the coast in central California, the winds blow from a consistent direction so that the water in the ocean rises up from the deep, and that's called upwelling. This upwelled water contains enhanced levels of methylmercury, and we suspected that it might evade into the atmosphere and possibly be absorbed by the fog droplets. Mercury enters the atmosphere from a variety of sources. One of these is from the combustion of coal. And mercury enters the atmosphere as a single mercury atom, Hg0. Here it encounters oxidizing agents such as bromine, chlorine, or the hydroxyl radical, which will symbolize as X. And these will cause the mercury to form a compound in the atmosphere. Now this compound, mercury 2+, is highly reactive, and it absorbs quickly into cloud droplets. And the cloud droplets grow and turn into rain, and they fall back to the surface of the earth. Now much of the earth is ocean, and so this rain adds to the ocean water, Hg2+ in the aqueous phase. Now the ocean has an interesting structure where the top portion is called the mixed layer, and it has plenty of sunlight and oxygen. But below the mixed layer is a region of low oxygen, and it is here where certain types of bacteria live, and they've learned how to survive under low oxygen conditions. These are called cyanobacteria. And part of their metabolism is to take up inorganic mercury, mercury 2+, and convert it into organic mercury, which is composed of two compounds, monomethylmercury and dimethylmercury. Now the dimethylmercury is volatile, and it evades out of the ocean and back into the atmosphere, where it is then oxidized back into monomethylmercury. Monomethylmercury is quite water soluble, and so it can be taken up by clouds and fog that are over the surface of the ocean, and this fog can move onto land where the droplets intercept leaves and drizzle down onto the land, thereby providing a source of monomethylmercury to the terrestrial ecosystem that was originally of marine origin. Fog water is collected for chemical analysis using an active fog water collector that has a fan and pulls foggy air in through the left side of this box, past the Teflon strings where the droplets collect, grow, and drip down into the sample collection jar shown below. This collector is automated such that when the relative humidity reaches above 90%, the doors open and the fan turns on, which pulls in the foggy air past the strings. The droplets drip down and fill up the sample collection bottle. Fog water samples were collected at sites in coastal California from Humboldt State University in the north to CSU Monterey Bay in Marina at the southern end of our range. The active fog water collector was also deployed on a ship called the Point Sur, and fog water was collected while at sea. During the day, the collector was cleaned to get it ready for fog collection at night. Fog was collected at ocean locations corresponding to the land collection sites. And this is what we found. All fog water samples, 149 in all, were analyzed for methylmercury, and the averages are shown here. Fog water collected at the land sites contained about 10 times higher methylmercury concentrations compared to those found in rainwater. Fog water collected out at sea contained about the same methylmercury concentrations as that found in rainwater. The land sites right along the coast nearest the ocean had the highest methylmercury concentrations compared to the sites that were several kilometers inland. After the results were obtained, myself and 2 undergraduates made a poster and presented it at the American Geophysical Union Fall Meeting in San Francisco in a special session devoted to understanding fog. Many media reports were made as a result of this research, including Chemical and Engineering News, The Good Times, and Popular Science. Okay, so now that we've found this mercury in fog and seen that it's enhanced over levels in rain, that methyl mercury is landing on the landscape around me. Is it making a difference? Is it accumulating in the environment? So we plan to look at mercury levels in top-level predators such as puma and other carnivores in the terrestrial environment. We also want to know how far inland does the mercury in fog penetrate? Does it go all the way to the edge of the fog belt, or is it confined right along the immediate coastline? And where in the coastal ocean is this methyl mercury evading from? Is it right along the coastline where the waves break, or is it coming from the whole area? And can we predict how changes in our climate will affect the amount of mercury that gets in fog? These are some of the questions that we're trying to answer. And until next time, fog on!